All right. So Will Lutman posted this lift on YouTube, trying to figure out the capacity of the machines being used. So what I've done is I have taken these two drawings, pulled them into Blender and got them to scale, and then made the 3D model of the lift. So you've got the walls, you've got the opening, you've got the kiln, you've got the roof, you got the building on the back, and you've got the roller on the roller there. Oop, wrong side. Um, so what I've done is I've used this one to get the estimated dimensions of the roller. I also estimated it to be roughly about a meter long there, based on this drawing with the axle going out the side. And so then what I did is I went in and so know the radius of the roller based off of the drawing, estimated the length to get a volume of 1.3, roughly 7 meters cubed. Same thing with the drive shaft, estimated it. So I've noticed that the drawing here is slightly different than this. So it looks like the drawing might be showing that one there. Um, so I just did what I had. So we got the radius there with the volume, combined the volumes, then found the density of steel. There's a range of densities, and so I determined always want to be safe, so I stood the densest steel density, and so that gives me 15,280 or 290 kilograms for the weight of this estimated. Okay. So then I was able to get it in game. So you can see you've got the roller down here. So I'm doing the lift backwards compared to what the lift plan shows. So the lift plan has it up here, you lifting it and dropping it down. But you've got the kiln, you've got the building walls, you've got the roof. All of them have collisions, so if the crane impacts them, I will know. So let's do the lift from the roller going up, and let's see what happens. All right. So we're going to slew the crane, keeping an eye on the ballast. One caveat: I am not a crane operator. Um, I have been getting tips from some people that are on the Discord server uh, that are crane operators. So just keep in mind, I'm not a crane operator, so I'm doing the best I can. Will, you see a lot of the pictures, he was a crane operator. He's been in the industry for quite a while. We've got him as a consultant for us. All right, so it looks like we got plenty of clearance from that back wall. Looks like the boom's about in the right position. So now we can extend the boom and thread it through the hole. So we can get that boom down just a little bit. So we're not going to hit the top of that opening. All right. Boom down right about there. Keep extending. Watching the roof up top. Alright. This is a pin boom, so the main cylinder is retracting now to extend the next section. I don't know if this is probably not how the actual lift, they'd probably pin each of the extensions about half or so. Okay, so now I'm going to boom up and boom out a little bit more so I can get boom in just a little bit. Okay, so now we should be able to lower the hook. All the way down to the lift point, which is that little green arrow. And so now the crane operator would be relying on their riggers. Obviously I don't need a rigger because it's a simulation. So I can move the camera around as I need to. But if needed, I can get out of the crane. So see, it's a solid wall, can't walk into it, it's gotta walk around it. But I can also walk around and see what's going on. All right, back to the crane. All right, so the hook's just about right. So we'll attach it, get the sling set up. All right, so moment of truth. Can the Terex 5500, also known as the 130 or 130, this is a 130 class, metric ton class crane. So let's see if you can lift it. Yep, good. Oh, I forgot to show you. This is the second time I've done this video. I did bring up the lift chart. So the boom, if we look at the boom, it's at 24.166 meters with a radius of a little bit over 15.5. So if we look, this is the closest I've got on the chart. Then we go out to 15.5. So between 14 and 16, we've got a lift capacity of 26,800 kilograms or 22,100. So 22,100, that's greater than the 16,000, or sorry, the 15,290 kilograms. So we should be good. So this is also showing that, yes, we are good. The crane is nice and stable for this lift. So we lift it up. Oh, okay. That is not the boom flexing. That is me accidentally, with my control, lowering the boom. So that's my fault, not the crane. That's the controllers. I'm using an Xbox controller right now. All right. There I go, booming down again. My fault. Okay, so now we have the load up above the pedestal that's going on. So now we're going to boom down and extend, trying to keep the angle of the boom as low as possible to make sure the boom does not hit that opening. All right, so let's do this. Okay, should be able to boom out just, nope, I am almost at the ceiling there. All right, I think that's probably good. All right, so we can see that the boom is not going to hit the opening. And we can lower the load a little bit and then get in a little bit closer to the kiln. Boom down just a little bit and boom out. There we go. All right, so now we can lower the roller right about there. So I'm going to slew right just a little bit and get that down. Awesome. Sweet. Glad to see it worked. Simulation works as it should. So yeah, thank you.